First thing, you had to look at what town you're working with. And so in y equals, you had to clear out downtown's function and put in uptown 6,000, parentheses, 1.018, close parentheses, raise it to an exponent. Second thing, you had to look at what they wanted. So this town started at 6,000 and then doubled to 12,000. Okay, so for the y2, if we're going to use intersect again, instead of 10,000, 12. Now we go second calc, 5 for intersect. One line looks good, second line looks good. First curve, enter, second curve, enter, guess, enter. And intersection at 12,000 is 38.9 years. And that's good. That's what I was seeing in a lot of your books. All right? C. How many years from now will the downtown and uptown populations be equal? Ah. What will that look like on the graph?
Two exponentials, like crossing.
Two exponentials crossing. So let's go back to y equals. That is uptown's formula. I need to go ahead and put downtown back in. 20,000, parentheses, 1 minus 0.015, close the parentheses, caret to make an exponent, add in a variable. I don't need a horizontal line or a flat amount. I'm not sure where the amount is. I'm going to go intersect again. So second calc, 5 for intersect. Here's uptown going up. Downtown coming down. It says first curve, and I see it blinking down here on the uptown curve. Good. Second curve, it's now blinking up here on the downtown curve. Good. Guess, yes please. Took a while. Don't see my cursor. Is it there? Or does it just...
Mine's in the middle.
You can see yours? Okay, it should be right there. But what I have is two numbers. I have a 36 and a y. It says how many years, and years are on the x-axis. Okay, so 36.5 years. Does it tell us to figure out the population? Use trace on your calculator to determine when the population of downtown was 0. Then determine when population of uptown. So trace, I don't know if we've ever used trace before, but I bet we can figure it out. Do you guys see the trace button? Hello? It's right between graph and zoom. Trace. Okay, you're going to use these arrows on your calculator, left, right, up, down, to trace. It looks like if I go to the right that I'm on the downtown one. Now, we want to know when downtown was 0, so I actually have to go to the left, bring it on back to the y-axis. The y-intercept is the 0, okay, and use a trace to determine when the population of, oh no, that's times 0. Oh, we got to go back to where the population is 0. Uh-oh. No, that's x. Okay, population is the y value. Do you see it getting smaller as you back your way up? smaller. We're trying to get the y down to 0. I've been clicking backwards and I'm at 1780. Keep going. Keep going. Keep going. Notice I'm at negative 97 years. We may run into our boundaries pretty soon. Negative 100. Oh, okay, it's going further. It has to think about it because, okay, negative 140. We're continuing to get further and further off our graph. Are we getting to 0?
Yeah.
Do we?
Teens.
What?
I'm in the teens.
Okay, now, what do you notice? Second graph.
All about that movie.
Oh, wait, second. Don't do second. Clear. Just graph. Graph. As we're going backwards and backwards and backwards, what's happening to downtown's graph? Does it look like it's going to cross? No. It is getting closer and closer to 0, closer and closer to that axis, but it's just skimming along the top. Okay? Determine when the population was 0. What do you notice? The line gets closer to 0, but doesn't cross the axis. Okay, there is a feature of exponential graphs where they do have this spot where it slows down how much they're going down. Oh, are they doing that or am I doing that? Here we go. They wanted to see my graph probably. The line gets closer and closer but doesn't touch the axis. Oh, I think maybe they need it up higher. You guys probably needed it up higher also. Okay. Determine the point at which each function is equal to 0 by graphing the line y. Oh, what'd you get?
What? Now no one did. I think this was the uptown.
Okay.
Negative 785.11.
Negative 785 years is when Uptown's population was 0, according to Jerry's very law of clicking. Okay, but what that ended up doing is we had to go farther and farther and farther off to the side to find it. They're telling us to try something else. Everybody go to y equals. We've got both functions in there. We'll leave them there. We'll go down to y3. Put in 0. Should have tried this from the start, yes? Put in 0. Okay. Second calc. Let's try intersect. First curve. Enter. Second curve. Enter. Guess. Enter. It's trying to find 0. Error! It can't do it. Okay? So it's saying it can't find 0 on these graphs. Alright? These graphs get error. Did you guys get error or did you get something?
I'm just completely off the track.
Error. Completely off the graph. Here's the main idea here. I'm going to sketch it to the side. There's our XY. Here's Uptown. If I was trying to find 0, what it's doing is getting lower and lower and lower, but very much evening out. Downtown kind of came down like this, and it evened out, even out, even out. It skims along the 0. 0 is the x-axis, and maybe way far out crosses, but a lot of times these functions get to a spot where they stop, and they will never cross it. They can get infinitesimally smaller and smaller and smaller, so much we couldn't even see them getting smaller, but would never cross. That's a feature of exponential graphs. Let's see what we have. Awesome! Are those guys good? Let me see if this is good. Ha ha ha! Okay. Each population function you graphed has a horizontal asymptote. Put a little box around that. And I don't say it right. Horizontal asymptote. Horizontal asymptote. Go ahead, give that a try. Asymptote. It's one of those kind of words, I think there's very few people who say it right, so say it fast and meld it all together. Asymptote. Okay? A horizontal line that the function gets... Okay. Hello, if you can hear me, snap once. Asymptote is a line that the function gets closer and closer to, but never intersects. Okay, write the equation for the horizontal asymptote for each population function. Not x, y equals 0. We were figuring out that it's the x-axis that these guys were approaching. Y equals 0. Does the horizontal asymptote make sense in terms of this population? Explain your reasoning. What does it tell us? What does it mean if the population never gets to 0?
There is no time.
Okay, maybe that would mean, how can you have an equation for a town before there was a town? Maybe it means there is no town. Okay, so if we're thinking about uptown who's going up, that means in terms of this function, it only describes after the town started. So you had to have somebody there. And in terms of downtown, is everyone going to move out? Well, if it never gets to 0, then they never all move out. So there is no town when y equals 0. Domain and range, let's not go there. Okay, I think we're already past our brain cells at the moment. Okay, so go ahead and we're not going to put the books away. Set it aside for a minute and get out your homework packet, please. Cool as a cucumber. This page is plug it in, figure it out. I think you guys can figure this one out. Okay? Take a look at the second page. Okay, this is something that people have had trouble with on the last 2 quizzes, so we probably need to spend some more time on it together. We're being asked to convert into a different form. So that means move terms back and forth, get maybe the y by itself. Slope-intercept form is y equals mx plus b. They show you how to do it, they show you how to do it for one equation. We're going to do it right here. We need to get y by itself. We need to get rid of the x term. Was a positive x, so I'm going to add a negative x to both sides of the equal sign. Guillermo, earphones out. What's left on this side is a negative 5y. It's important to keep that negative in front of the 5. Now this x and that 25 are unlike terms, so I'm just going to write them side by side. They don't actually subtract. Okay, so I'm going to go minus 3x, and I'm going to move the 25 over. Now I want to get that y and have it not have this 5 in front. I need to divide. So the first thing I did was move the x term by adding the opposite. Second thing I'm going to do is get y with no number in front by dividing by the negative 5. Y equals, nothing can reduce here, gentlemen. But the 3 and the 5 both had negatives. 2 negatives cancel out when we're dividing or timesing. What's 25 divided by minus 5?
Negative 5.
Negative 5. Okay, so this is slope-intercept form, or y equals form. This is standard form. Let's take a look at number 9. Make it bigger. I want y by itself. How do I get rid of that negative 4x? Add it here and add it on the other side of the equals. 9y equals. How do I write this 45 and 4x now?
4x put in front of that.
4x plus noodle. Okay. Now I have a 9 in front of the y. Divide by 9 here. Divide by 9 here. Divide by 9 there. I want the headphones out, Guillermo. This side is y equals 4 over 9x. 45 divided by 9 is... Alright, so you should have nothing in front of the y. It's okay to have a fraction in front of the x. It's okay to have a fraction here, but so far 2 of them are divided out. That's our answer right there. So that's what you're going to do on these problems. The other ones, I think I'm going to give you a little bit of time to practice that while I walk around. Because again, this has been a problem area on the last couple of quizzes.